Hello guys, hope we are all doing good. Um, I just wanted to revise the notes with all of us because I remember this day we were talking about network topologies. Not everyone was in class, and please make sure you read all the slides I've given so far. I think I this is the first slide, and after I think everyone has this already. The second slide we'll talk about it after this, shortly after this, and I will send it after this video. So network topologies, that's where we stopped. And so what is a network topology? I hope all of us know what networks are already. uh, so what is a network topology? We say topology defines the structure of the network, of how all the components that are interconnected to each other. There are two types of technology, that's physical and logical topology. All right, let's look at the first statement that says it is the structure of a network, of how all the components are interconnected with each other. All right, remember we said in a network, uh, there are many devices that are concerned. That's what we call network devices. And some of these devices can be a router, a switch, and the other devices you might know, even your modem is a router. Some other network devices can be your computer, a printer, and so on and so forth. So basically, we are saying that the structure of that network, how the network is going to look like, the architecture, yes, of the network is what actually we call the network topology. How all of those various components, meaning that if you're supposed to be keep placing network devices like let's say a hotspot or an access point which is used to share network with everyone wirelessly, where are you placing them? How do you place those various components, and how are they connected to each other to make sure that you receive uh, connection or network from wherever you are within the region of the network coverage. So basically, that's what a topology means. So we say there are two types of topology. We have a physical topology and a logical topology. And we say a physical topology is a geometric representation of all the nodes. Talk about nodes now. We are talking about the network devices. Yeah, all the nodes in a network. So the arrangement of a network that comprises nodes and connecting lines via sender and receiver is referred to as network topology. Listen to this definition very well. The arrangement of the network, right? And we say it comprises the nodes and the lines. Those lines can be the cables, yeah, and let it be wirelessly, let it be a connecting line that is wireless or is wired, yeah, and then the nodes, we said these are the networking devices. Now between the sender and the receiver, now if you're connected to a network, obviously there's someone that is uh, uh, can be playing the role of a sender, and then you who is just using the network, you are you can be referred to as a receiver, you understand? So the person is offering the network, or the device that is sharing the network, can be considered as the sender. You who is using the network, your own devices to connect to the network, you can be referred to as a receiver. So we say that the arrangement of that network, remember we say it's a structure, is an architecture, and then between the network devices and the connecting lines between you, the user, and the administrator or the server is what actually we call the network topology. So there are various types of network topology, and the first we're going to be looking at is the mesh topology. And we say in a mesh topology, every device is connected to another device via a particular channel. So here, as you can see, this is a node, this is another node, this is another node, and these are the connecting lines. Voila, these are the connecting lines. So basically, every device is connected to another device, and there's a particular channel through which all of those devices are connected to each other. So one way or the other, if this is computer A, right, this one here, and this is computer B, so we are saying that computer A and computer B are connected to each other, computer A and computer C are connected to each other. So every computer is connected to every other computer within that network. Yeah, that's mesh topology. So we say if you go one, every device is connected with another via dedicated channels. These channels are known as links. So suppose n number of devices are connected with each other in a mesh topology. The total number of ports that are required by each device is n minus 1. In figure 1, there are 5 devices connected to each other, hence the total number of ports required by each device is 4. That's right. Total number of, yeah, is 4. Total number of ports required equal to. Alright, so that's a very basic calculation that we can do. So in this kind of topology, right? So we have 5 devices. So we are saying that each device here, or each computer, is supposed to have 4 extra ports. What are the ports used for? The ports are used to connect each computer to the other 4 computers. For example, if you take the topmost computer here, which is let's give it the name computer A. Now, how many computers are left? We have one, two, three, four. 4 computers are left. So now all of these computers, these 4 computers are connected to computer A. So how many ports do you are supposed to be available for you to connect all of those computers via cable? 4 ports are needed, and so the formula is there, and that formula is what, to calculate the number of ports for each device is n minus 1. But now, if you are supposed to calculate the number of ports required for uh, a whole mesh topology like this one, the formula is total number of ports required equal to n times, in bracket, n minus 1. Now, n is the total number of devices in the network. So in this network, how many devices are there? There are 5 devices, right? One, two, three, four, 5. So you put the n times, in open bracket, n minus 1, or n is 5, so it's going to be 5 times 5 minus 1. 5 minus 1 is 4, so we're going to have 5 times 4, which is 20. So these are the total number of ports that are required for that particular topology, or for that particular network. So we say suppose n number of devices are connected with each other in a mesh topology, then the total number of dedicated links required to connect them is nc2. That is n, open bracket, n minus 1, close bracket, divided by 2. All right, we say in figure 1 there are 5 devices connected to each other, hence the total number of links required is 5 times 4 divided by 2 equal to 10. All right, so here it is the links that we're talking about. What are these links? These links are these lines. Look at the lines. Let's count the lines together. 1, 2, 3, 4, 5, 6, 7. Right? 8, 9. I think there should be 10th one, which I'm not seeing. Okay, the 10th one is down here. 10. So if you count it your own eyes, it's supposed to be 10 in this particular topology. But now this particular formula, how would I put it? This particular formula um, explains everything. Yeah, it's very easy. So the formula is n raised to the power n minus 1 divided by 2. So when you do n minus 1, you divide it by 2. Yeah, and then you have your required answer. So we say that n is the total number of computers, right? So if it is 5, total number of computers, so you put 5 times 5 minus 1 is 4. 4 divided by 2 is 2. 2 times 5 is 10. That's why we have 10. If you count it with your physical eyes, you notice that the lines are 10 of them. All right. So the advantages of this topology, we say it is robust, and the fault is diagnosed easily. Data is reliable because data is transferred among the devices through dedicated channels, provides security and privacy. Problems with this topology, or the disadvantages, we say installation and configuration is difficult. The cost of cables is high as bulk wiring is required. So here we actually use cables, right? So the cost of maintenance is very high. That's true. If the cables are high, the use of cables are high. This means that if one cable is broken at a point, you don't join the cables. You have to replace to get a new cable, and so getting new cable, that's very expensive, right? So maintenance is really high at this level. All right. The second type of topology we have is the star topology, and we say in star topology, all the devices are connected to a single hub through a cable. This hub is the central node, and all other nodes are connected to the central node. The hub can be passive in nature, that is, not an intelligent hub such as broadcasting devices. At the same time, the hub can be intelligent, known as active hub. Active hubs have repeaters in them. Yeah, I think uh, this is very, very understandable. But then let's look at it sentence by sentence. Yeah. So we say in star topology, all the devices are connected to a single hub through a cable. So all devices are connected to one hub, a central device. Yeah, a central device through a cable. Now we said this hub is the central node and all other nodes are connected to the central node. So we're talking about the hub, right? So the hub is like any other device, but then it is the central device. It's like the administrative device, and that particular administrator or administrative device, right? All other other devices are connected to it, and that particular device is called the central node. The hub can be passive in nature, that is not an intelligent hub such as broadcasting devices, and at the same time the hub can be intelligent known as active hub. So we are saying that if the hub is passive, right, so we can call it an it's not an intelligent hub. So an example is that broadcasting devices. At the same time, the hub can be intelligent known as active hub. So we have two types of hub, passive hub and the active hubs. So now the differences between a passive and an active hub is that an active hub is intelligent, a passive hub is not intelligent. Active hubs have repeater in them. So that's another difference between a passive hub and an active hub. Yeah. So that's an example. We have the central hub here in the middle, and all other devices or all other nodes are connected to the central hub. All right. We say in star topology, all the devices are connected to a single hub through a cable. Okay. Oh, sorry. I think this is just a repeat. Yeah. This is just a repetition. Yeah. So we have more than this, but then I think we just need to go and read more. So this was an assignment that was given to all of us. So make sure we also study this assignment, which is very important. All right. So we have the bus topology, we have the tree topology. I didn't mention that, but then we all have to study those topologies. Yeah. So let's move on to the next lecture. And the next lecture, this lecture, I just decided to choose some topics that we are going to be talking on because I cannot evaluate on all the topics, but then decided that let's look at this group works together. Yeah. And the first one we're going to be looking at is artificial intelligence. So, artificial intelligence, when people hear about it, they have this impression that this is something that is really huge, something that we cannot understand. So, what is artificial intelligence? So the answer is the power of a machine to copy intelligent human behavior. If a machine or a device or a software has that capability to copy intelligent human behavior, then that can be called artificial intelligence. Yeah, it's artificial, man-made, right? Yeah. So there are some diagrams here of some things that we are versed with. There's the first one, I think, if it's Star Trek, or yeah, I don't remember the movie, but yeah, there's this particular device that was there, and then the one in the middle we can see it's a robot, yeah, that does the chores of a human being and think like a human being, and everyone remembers this Transformers. That's Bumblebee. You know, Bumblebee, according to Transformers, is actually a being, an extraterrestrial being that's from another planet, from another universe or whatsoever. But then it can think on its own, right? And it can speak for its own. It takes its own decisions. Yeah, but then it's a machine. So basically, it is intelligent. It copies human behavior. Yeah. So we can call it an artificial intelligence too, but not with respect to the movie though. But then, if you want to understand it, um, with respect to tech, then that is an artificial intelligence robot. So, robot at Artemis. So we say, are robots intelligent? All of these are robots. All what you see there are robots. Some robots are just there, like the one in the middle. Yeah, they are just there to serve one purpose, Either they serve as alarms, some are alarms, some and so on and so forth. The other one that you see the other way is a robot. This kind of robots are usually sent to space where humans can go. They go on behalf of humans and they do things that humans can do, maybe because it's very risky. And that's another robot that's carrying an object to go and deliver somewhere. So basically, these are robots. So we say, are robots intelligent? We said a robot is only as smart as its initial program. So if you program a robot, right, to pick a device from point A to point B, the robot executes that. If you program a robot to go and pick a gun and shoot at somebody, the robot is going to do that. If you program a robot to say, okay, if you see somebody holding a gun, shoot. If you see someone not holding a gun, don't shoot. A robot will go and will analyze somebody, and if he sees a weapon, he will shoot. If he does not see a weapon, he won't shoot. You understand? So basically, that's what a robot is. It only do as what you demand, what you have programmed it to do. Yeah, the next picture that you see below there is just an example of what a code looks like. Sorry. So we said the power of a machine to learn and copy from an individual, that's what we call artificial intelligence. But then, is a robot able to learn and copy from an individual? No, except if it has an artificial intelligence capability. All right, so let's try to compare artificial intelligence to robots. So we say AI, that's artificial intelligence. And we have robots. We say AI is programmed to think, robots are programmed to do. That's the difference between them. Now, a robot can use AI, but not all robots use AI. Because some robots, their job is just to pick this, drop there. Robots do this, do that. So they're programmed to do. AI is programmed to think. AI has the capability for social interaction. The interaction of robots is very low. That's why we say low level interaction. AI learns. Robots are as smart as their program. That is, they do what their program requires them to do. Yeah. So let's look at some artificial intelligence tests. The first one we have is the Turing test. And we say it's developed by Alan Turing and involves an interpreter, a human being, and a computer. So basically, we say the computer and human have separate conversations with the interpreter. The interpreter can't guess which is the computer, or if the interpreter gets it wrong, then the computer has that we say sorry, then the computer has artificial intelligence. This line is a continuation of that. Let me just fix that so that we won't have any problems later on. All right, sorry for that. So we say, let's start it back. So we say the computer and human have separate conversations with the interpreter. So basically, the interpreter is helps convert high level language programs to low level language programs. Yeah. Remember we talked about the differences between high level language programming and low level language programs. So high level language programs is for computers. Sorry, human beings understand high level. So the English I speak is a high level language program, and then the computer understands low level language program. And most of the times, those low level language programs are actually for uh, computers to understand. Yeah, if the interpreter can't guess which is the computer, or if the interpreter gets it wrong, then the computer has artificial intelligence. So look at this. The test here is for the interpreter to determine uh, which one is the computer, which one is the human. So basically, the computer will discuss with the interpreter. The human being is going to discuss with the computer. So now, the sorry, human being discuss with the interpreter, computer discuss with the interpreter. But now, if the interpreter is able to succeed and guess or determine which one is the computer and which one is the human, then the computer does not have artificial intelligence. But if he is unable to do that, then we say the computer has artificial intelligence. Why? Because he's going to be testing for the intelligence of both of them. The computer in its normal sense is not intelligent. It does what you ask him to do, or you sorry, it does what you ask it to do. Yeah. So the next test is the imitation game test. So we say it involves two sets. First test involves an interpreter, a male and a female. All right. Female pretends to be a male. Interpreter tries to figure out who is who. Second test is similar to Turing test, compares both tests. So the imitation game test is that the female is going to pretend to be the male, right? And the interpreter tries to figure out who is the male, who is the female. So the second test now, so that's for the first test. The second test now is similar to the Turing test, right? Remember what the Turing test does, and then the Turing test is simply going to with the computers have a conversation with the interpreter, the human being have a conversation with the interpreter, and if the interpreter is unable to determine which one is the human being and which one is the computer, then the computer is certainly having artificial intelligence. So after the first test and the second test, the computer compares the two tests are compared with each other. So that's the second test to know whether a computer is having artificial intelligence or not. So Turing test, we say that Turing tests the computer results to itself and not humans. Imitation game, the imitation game test compares both the robot's results and the human results. So it compares both of them to see, to be able to identify actually if the computer has or the robot has artificial intelligence or not. So some examples of artificial intelligence programs, we have the Cleverbot. You can Google that to find out more about Cleverbot. And we have autonomous cars. Autonomous cars simply means that the cars do not have drivers. You understand? You just enter and you sit, the car drives itself. So it's using a program, an AI program or an artificial intelligence program, so that if it meets an obstacle, it stops. When it sees a red light, it stops. Green light, it goes. You understand? It reads all of this. So we have drones too, who are some drones are also intelligent. Yeah. So some problems you say, although AI is advancing, it can still be problematic. So we see some two screens there with two people who are they're not real people. I say you were mistaken, which is odd since memory shouldn't be a problem for you. So that's just a conversation between two artificial intelligence systems. So part of the problems are the controversies we are talking about. So those are problems. So on the picture, you see a lady going to open a door and is reaching their computer date, and she goes and gets her date, which is a robot, and she's moving out with the robot. So basically, it looks somehow funny, but that's if care is not taken, the world will be getting to this point one day where people are going out with robots. Basically, I think people do it already. People are addicted to their phones. Yeah, I'm not saying that a phone is a robot. I'm not saying that's an artificial intelligence system, but if you can be addicted with your phone and you trust your phone more than a human being, more than your parents, more than your partner, more than your siblings, then you are simply doing what this lady is doing on the picture. So the controversies are that potential job takeover. AI has is actually taking over some people's jobs. I gave this story to some of you, and I believe you know that already, where I was talking about uh, this Alibaba Group hotel in China. So at the entrance of the hotel, right, before you get to the hotel, yeah, you actually book for a room. And when you get there, you kind of confirm your reservation. When your reservation is confirmed, at the lobby, there is a robot that gives you a tablet, and then another robot comes and takes you to the room. So while in the room, before you enter, there's actually a camera that scans your eye retina, because you must have scanned your eye retina to confirm your registration downstairs. So when you go to your room, it scans your eye retina, your door opens. When you're inside, you need anything, just pick up your tablet, place an order, and the robot is going to give it to you. So just look at this. Most of the times, those robots have artificial intelligence systems in them. So how many jobs the receptionist has been replaced? The person who is coming to deliver your order to your room, that person, that delivery guy or that delivery girl has been replaced. You understand? So the jobs of people have been taken over by computers. So it grows laziness. Many people become lazy because they don't want to actually do things themselves now, because computers do it for them, robots do it for them, or AI does it for them. Let me take an example of AI, right? Uh, there's this particular story I watched it in a comedy, and what actually happened was the fact that uh, there's this guy having his girlfriend. He was actually cheating on his girlfriend, and he was using an iPhone. And what he simply did was he his girlfriend took his phone and she locked herself in the bathroom, and he didn't know how to do, and it was really dangerous. She knows his password. So what he's no no sorry, it was unlocked. She didn't know his password. It was unlocked and she didn't know his password. So what he did was he just said, "Hey Siri, lock my phone." Automatically, Siri on his phone, which is an AI which is for voice recognition, recognized the owner's voice and locked the guy's phone, and his girlfriend could not use the phone again. You understand? So that one way or the other, many people can just speak to their phones execute, "Hey Siri, call," you give the name of the person, it calls the person. Yeah, Siri just opened on my phone actually. All right. It was about calling somebody, and it even picked a number from my phone to launch a call. I had to cancel it. So that's simply it. So this Siri, Google Assistant, all of them, they actually grow laziness, growing cost. To be able to maintain all of these systems is so much money, yeah. And so we have priority argument at times with AI. To be able to identify which one is a priority, it's not actually easy for it to determine which one is a priority. We are humans, right? We have our own ways of knowing which things are priority, which are not actually by the book. But then with the artificial intelligence system, it follows the book to the letter. So robot relationships is actually a question, it's a debate. You think that you would see people having relationships with robots in future? I would say yes, and I would say no, depending on which point of view, from which angle you view this. So the kind of relationship that exists is going to be that people will be picking robots and placing their houses to be house helps in future. They even exist already. Yeah. But then there are a lot of applications of AI though. So why does it matter? We say in the future AI is going to be everywhere. It is important to know about it and understand it. This is because we may be interacting with it on a day-to-day basis. We learned at Artemis about the different robots that use AI. Remember, that's Artemis. We saw the different robots that use AI. We also learned when robots need AI and when they don't. Right. So that's actually why it matters. So, artificial intelligence is no match for natural stupidity. And that's what will confirm my own point of view about the fact that uh, at times AI does things by the book, but we at times our priorities are different. Yeah, we use emotions. Some AI have emotions, but not as us. AI cannot have our own kind of stupidity, you understand? But in our stupidities, at times, it makes so much sense. So, that's it about artificial intelligence, but just know that artificial intelligence have a variety of applications in health. In the health sector, it has its own application, but I want you to know how artificial intelligence is actually applied in the health sector, even the educational sector, in the military sector, and the financial sector. In fact, any other sector that exists, just know how artificial intelligence can be able to be applied in those various sectors. All right, so let's move on to the next topic. That's cloud computing. So we say cloud computing provides us with a means by which we can access the applications as utilities over the internet. It allows us to create, configure, and customize applications online. With cloud computing, users can access databases resources via the internet from anywhere for as long as they need without worrying about any maintenance or management of actual resources. What is cloud? The term cloud refers to a network or internet. Yeah, when we talk about cloud, it's not the natural cloud that you see with your eyes. You can't see that kind of cloud. So it's digital. So you said it refers to a network or the internet. In other words, we can say the cloud is something which is present at remote location. Cloud can provide services over the network, that is public networks or on private networks like WAN, LAN, VPN. Remember we did that already. So WAN wireless area network, LAN local area network, VPN, virtual private network. Applications such as email, web conferencing, customer relationship management, and CRM all run in the cloud. Why? When you use something like web conferencing, for those who have used Zoom before, you notice that that particular Zoom or that particular meeting is not found in your phone, it's not stored in your phone. No, it's happening somewhere, various locations, but you're able to use some of these kind of resources from your own location, from your own house, from your own wherever you are. Now, uh, um, emails, when you write emails, do the emails stay in your phone or your laptop? No, it's actually on the cloud, but then your phone can be able to access it anytime, any day. Now, we talked about customer relationship management. So there's this software that people use at times, companies use, we call them CRMs. Yeah. So it doesn't stay on the computer, it's actually online, and people have their logins. They have various actions for this customer relationship management software. Yeah. So we talked about the cloud. We know what the cloud is now. What is cloud computing? We say cloud computing refers to manipulating, configuring, and accessing the applications online. It offers online data storage, like your Google Drive. Google Drive is an online data storage. You're able to store things there, Google Photos, infrastructure, and application. So some people usually have their IT infrastructure in a remote area. You can be Cameroon, you have your IT infrastructure somewhere in Kuala Lumpur, that is in Malaysia. You can have it in Australia, anywhere. Yeah, but you're using it from Cameroon. And applications like email, your Gmail is an application. You are using it, but it's hosted on a cloud. Cloud computing is both a combination of software and hardware-based computer. Sorry, we say it's a combination of software and hardware-based computing resources delivered over a network service. So I think that's one of the easiest definition, but then it's still a continuation of the previous statement. So we say that it is a combination of software and hardware computing resources delivered over a network service. Okay, I think that one is a repetition. Sorry for that. All right, cloud computing architecture. So let's look at the basic concept. We say there are certain services and models working behind the scene, making the cloud computing feasible and accessible to end users. Following are the working models for cloud computing. So what you have to know is that there are services and models that are actually working to be able to make the cloud computing functional, to be able to make it feasible and accessible by you. The fact that you're using email, you're using Google Drive, Google Photos, and you're able to use other stuff, yeah, or people who are gaming and they don't know where the game is found, but they're just playing game. It's not found on their laptops, but they're playing it online. You need to ask yourself, where are they found? So basically, we said that those services, they have what we call services and models. So where are they and what are they? So following are the working models for cloud computing. So the models we talk about here are two: deployment models and service models. So let's look at the first one, which is deployment models. I will say deployment models define the type of access to the cloud. Yes. Which kind of access do you have to the cloud? That's what we call deployment models. How the cloud is located. We say cloud can have any four types of access. We have public. So there's the various kind of access, or the various types of access are public, private, hybrid, and community. So let's look at them all together. Public cloud. We say the public cloud allows systems and services to be easily accessible to the general public. There's no restriction. Everybody. Public cloud may be less secure because of its openness, e.g., email. So we say that it's open to the general public and is less secure because it is open. An example of that is the email. So um, next type of deployment model is the private cloud. The private cloud allows systems and services to be accessible within an organization. So organizations usually have the private cloud. It offers increased security because of its private nature. Next one is the community cloud. The community cloud allows systems and services to be accessible by a group of organizations. So that one is, there's a particular category of people or organizations that can be able to use the community cloud because it is meant for those kinds of community or organizations. Hybrid cloud, we say the hybrid cloud is a mixture of public and private cloud. However, the critical activities are performed using private cloud while the non-critical activities are performed using the public cloud. So many companies use this. So they take a blend of the public cloud and the private cloud together. Service models. Service models are the reference models on which cloud computing is based. These can be categorized in three basic service models listed below. So we have the IaaS, that's the infrastructure as a service. And now we say infrastructure as a service is a delivery of technology infrastructure as an on-demand scalable service. So this one is actually a delivery of technology infrastructure. We're talking about technology infrastructure. So just imagine. Let's finish, then we explain. Infrastructure as a service provides access to fundamental resources such as physical machines, virtual machines, virtual storage, etc. Usually built based on usage, usually multi-tenant virtualized environment can be coupled with managed services for OS and application support. So with the infrastructure as a service, right, a company might be needing some kind of storage for its company resources. Like each time a document is coming in, you are scanning, you are keeping them somewhere, but then you are afraid that if your computer burns down or gets bad, you will lose it. So you get like a cloud provider that gives you that possibility, infrastructure as a service. Now you're able to store, you can use the virtual storage to store the company's files. Now you can have virtual machines. Maybe you need powerful servers, powerful, but you can't actually have the physical computers because they're very expensive for your company. You can actually use them virtually, but then those real computers are somewhere, let's say in in California, but you're here, you're able to use those machines, but virtually. Yeah. So this we call infrastructure as a service. So you use an IT infrastructure on demand. That is, you want to, when you want, you demand for it, they give it to you, and that it can be scalable. If your company is growing, it can be able to grow easily. You don't need to buy extra hardware to add. What you need to do is, as your demands are growing, that's how the billing is growing. So they, you pay for what you use. If you're asking for three CPUs, maybe the processing power of three CPUs, or you want to use, yeah, three CPUs, you pay for only the three CPUs. You don't pay for 10. Now, as your demand is growing, maybe your many people are using your systems, and so you need maybe 20 CPUs. That's how you pay for 20 CPUs. It's not as if you buy 20 CPUs and people are not using, or you buy 20 CPUs and you have people that the people you have can those 20 CPUs are insufficient for them, and so you need to buy more. No, it doesn't work like that. Next one is platform as a service. So platform as a service provides the runtime environment for applications, development and deployment tools. Platform as a service provides all the facilities required to support the complete lifestyle of building and delivering web applications and services entirely from the internet. Typically, applications must be developed with a particular platform in mind. All right. So here we say it is an environment to run and develop applications. So you want to develop applications online. Yeah, develop, you want to develop, run it and deploy it. Platform as a service is the kind of service model you should use. So we have software as a service model, which allows you to use software applications as a service to end users. So software as a service is software delivery methodology that provides licensed multi-tenant access to software and its functions remotely as a web-based service. So here we say that, let's start with the first statement, allows to use software applications as a service. So an example is email, right? You're able to use a software. You're not the one who developed the software, but you use the software. Email, some people use Instagram, some people, all of this, you're not the one who developed it. It's not hosted on your server, but you're just using it. Yeah. All of this cloud, all of this software you use that needs internet to run, most of them, those can be categorized as software as a service. Email is an example, as I said earlier. All right. The question is, do you use the cloud? Someone will say no, but I will say yes. For most people who use smartphones nowadays and they're asking you put an email address for the device to function, one way or the other, you're using the cloud. Either directly or indirectly, you are using the cloud. So the advantages, these are the advantages and yeah, and disadvantages of cloud. So we have some cloud computing providers. We have Amazon Web Services as the top in the market, AWS. We have Server Space, Microsoft Azure, we have Google Cloud Platform, we have IBM Cloud Services, Adobe Creative Cloud, Kamatera, VMware, Rackspace, Red Hat, Salesforce, Oracle Cloud, SAP, Verizon Cloud, Navisite, Dropbox. I think many people are versed with Dropbox, Oracle Cloud, VMware, Adobe Creative Cloud, Google Cloud Platform, Microsoft Azure, AWS. Many people are versed with that, but the world is actually going towards cloud computing. That's a disruptive technology. The next point here we're going to be talking about is Internet of Things. Internet of Things. So we say Internet of Things is a system of devices connected to the internet with the ability to collect and exchange data from users or environment with no human intervention. It is a system of devices connected to the internet with the ability to collect, exchange data from users or environment with no human intervention. The device or the thing in IoT uh, could be any device embedded with electronic software and sensor like a smart refrigerator, a smart air conditioner, lights in household, connected security systems, or even a person with a heart monitor or an automobile. So uh, let me try to explain to you what an IoT is, right? So an IoT is a system of devices that are brought together. It's a collection of devices that are connected with each other. Now, these devices use either a network or the internet. So it has this ability to be able to send data to users or even collect data from users. And it has the ability to also influence things in the environment without human intervention. Let's take an example. So some houses, right? When places are getting dark, the lights come on alone, and when day is breaking, lights go off alone. That can be called Internet of Things. Now, it's having what we call a sensor, right? It's having a sensor. That sensor now is embedded with electronic chips and so on and so forth. And it's having its software. The software tells it that, okay, you sensor, you are the one to detect whether uh, it is night. If it detects that it is night, then the software tells it, come on. Now, if day is breaking, it tells the sensor, hey, sensor. This computer program tells it, hey, sensor, day is breaking. Please put off the lights so that you economize electricity. So that's how IoT basically works. So why IoT? People are very lazy. People want to automate everything. People want to control everything remotely. Yes, I have seen someone who is somewhere at work and he's picking up his phone and he's looking at his house. He said, "Ah, I forgot to put off light in my room." And picks up his phone, open an application, put off the lights, the bulbs in his room from a distance. We want to see data in real time. People who use IoT in agriculture, some of them they put the sensors to know to study the soil, yeah, to know which kind of manure or fertilizers to apply, to study the atmosphere, to study. So basically, those sensors collect data in real time and sends it to the users. Sensors are fitted everywhere across every device is collecting real time data consistently. I said that earlier. Every device has its unique ID, which makes the communication possible among them. Applications. So this can be applied in building and home automation, environment monitoring, medical and healthcare systems, smart transportation, smart manufacturing, energy resource management, etc. etc. If you want to know more about that, you can Google any of them and then you see the applications in real time. So example, the camera can monitor the road for congestion, accident and weather conditions and communicate that data to a gateway that combines it with data from other cameras, creating an intelligent citywide traffic system. Let's say city's intelligent traffic system detects massive congestion due to an accident. That insight can be sent to the citywide transportation system, which can analyze and derive optimum routes around the accident and send those instructions to cities digital sign systems to guide drivers around the accident. So this is basically what it's doing. So the camera checks sees the road. The camera is fixed on the road. We have those cameras in Yaoundé, but then those cameras are just used to monitor. That's all. It doesn't have any IoT. So generally, uh, cameras, let's say in the Western world, what they do is that these cameras see if there's any congestion, any traffic, it sends it, updates it with other uh, applications, and those applications, even users, drivers can be able to check where there is a traffic, and the application is able to give them an alternative to say, okay, you can be able to follow this way. This way has less traffic and less congestions, and they follow that way. So basically, you see how IoT works. So there's a sensor in that particular camera that is looking at the traffic, and then now it's connected with other cameras around the city and says, okay, if this road is blocked, there's an alternative. This one is not blocked. This one is passing freely, and proposes to you that pass through this way. It helps because. The police force cannot know everything at the same time. So just imagine that the police is here. They don't know maybe at Carrefour Bastos there's traffic there, or at Longkak there's traffic. So basically, the camera does that automatically without human intervention. So these are some few challenges which we can read. Yeah, and conclusion. Okay, let's move on to the next technology. That's blockchain technology. So let's look at the brief history. We say in 2013, one Bitcoin equals 100 USD. 2014, Microsoft accepts Bitcoin. In 2017, one Bitcoin equals 10,000 US dollars. So in 2013, one Bitcoin was equal to 50K, or let's say 550K. In 2017, one Bitcoin was equaling 5.5 million. Yeah. So you see, just space of 5 years. And right now, I don't even know again. So one Bitcoin is actually millions. If you have one Bitcoin, you're a millionaire. Just know that. Yeah. So um, many people are trying to uh, confuse the difference between Bitcoin and blockchain. So I think from this you should be able to know the difference. Bitcoin is an application of blockchain technology. Blockchain technology is the underlying data structure which can be used for many things, including cryptocurrencies. So blockchain is not only used for cryptocurrencies like the Bitcoin, but it can use for many to do many other things. So now Bitcoin is just an application of the Bitcoin technology. So there are many other applications of the blockchain technology. So I hope you have grasped the difference between Bitcoin and blockchain. So what is blockchain? We say blockchain is a data structure which is a growing list of data blocks. A data block are, the data blocks are linked together such that all blocks cannot be removed or altered. So basically, these are the various blocks of data we're talking about. And we say that these data blocks are linked together. And now each data block is linked to another via what we call a reference. It's pointing to the reference of another data block. So basically, that's what a blockchain is, the technology is. And now let's talk about the Bitcoin's ecosystem, a public network in which anyone, including a malicious participant, can participate without restriction. Yeah, on the Bitcoin ecosystem, anyone, or let's say the blockchain technology, anyone can be on the network, and it can, even somebody who is a hacker, a scammer can be there, but then everyone can participate without any restriction, even though it is not organized by a central authority, it works. So our police force cannot control anything there. You understand? That's why people love it that much. Bitcoin ecosystem, we say that's more security, increased Bitcoin value, it has more participants. Awesome. So with blockchain, what it does is that all those central authority like banks, it removes them, meaning that you can send money from one person to another directly without any middleman, without the government, without the bank. Yeah. Building consensus. After a finite time, all participants agree on a single stake who owns how many Bitcoin. So that's how it actually works. And people do their buying and selling with how many Bitcoins you own. So it's just kind of a digital currency on its own, right? So if you have any questions, don't hesitate. My numbers are there, both numbers on WhatsApp. So feel free to write to me on WhatsApp and I will be ready to answer. Thank you very much. Have a nice time.